Hello, hello, hello. If you're watching this, you missed day 2 of our week 18 lecture in computer science principles. Let's get going. So we got a short warm-up, then we're continuing with lists, and there is an assignment due Friday, and the assignment is to practice some very basic list operations, so we'll take a look at that later. My objectives are that you can identify common programming patterns using lists, explain the purpose of programming patterns with both lists in terms of how they work and what they accomplish, and lastly, modify apps that use common programming patterns with lists to adjust their functionality. So lots of big words, but all it boils down to is you know how to use lists. You know what makes them tick. You know how you want to use them. Now, here we have a very straightforward warm-up. What are some similarities and differences between lists? Well, of course, lists are just a collection of variables. Is an easy way to think about it. But this question here is a little more interesting. How does a list manage complexity? So we've talked about managing complexity in the past, but we didn't really explicitly define what I mean by that. Managing complexity is when you make your code easier for people. Not easier for computers, but easier for yourself and others to follow, structure, and understand. So one way that you can use lists to help you manage complexity is if you're going to have a bunch of similar items. Like, let's say you're going to have a whole list of groceries inside your program somewhere. Instead of creating an individual variable for each one, if you have them in a collection like a list, it can make it a lot easier to read and understand your program, which is what you want. Now, of course, lists also give you additional functionality, like being able to add additional information to your program as you run it, which you wouldn't be able to otherwise do. But that's a different use. That's not a managing complexity use, it's just a functionality use of this structure. All right, so here there's a video, it's really short, about how to find the length of a list. I want to point out one quick thing about this. Right here, when we go to find the length, first of all, notice there's no parentheses after the dot length. We'll talk a little bit later about why that is. We don't quite have enough knowledge about programming concepts yet to really explain this, but just remember that the syntax for this doesn't have parentheses. The second thing to keep in mind is if you want to get the last element in your list, this is a good way to do it. You would get the numList.length, which would give you the length of your list, in this case 1, 2, 3, 4, 5, 6, since there's 6 elements. And then subtracting 1 will always put you at the last element, since we start counting at 0. So this would dereference the list at 5, and it would return 40. So this is an important idea that you're going to probably have a lot of opportunity to make use of. From there, we went on to do the list investigate activity. So here there's a bunch of bubbles with some interesting programs for you guys to peruse and see how they work that use lists. So this one has 2 lists, a tops list and a bottom list. The tops list holds all the tops, and as I scroll through them, there is an index that keeps track of where I am in the tops list. There's similarly an index for the bottoms list, and that one holds all the bottoms. Now the trick here is you guys are probably going to want to do something like this. You're going to want to have an index that you use to keep track of where you are in your list. Please make sure you name your index something descriptive. Do not name it index 1. Please, please, please. That is not descriptive. That is going to leave a lot of people guessing what you're trying to accomplish there. Please, use descriptive naming. All right. Another thing to note here is there is this check that occurs on line 32 and also line 18. And what this check accomplishes is it checks to see if the tops index, when I click the button, is less than the tops list, my goodness, dot length minus 1. What does that mean? Well, it basically checks to see if we haven't gone out of bounds. If I have my tops index be equal to its length, or larger, we know for a fact we've gone too far, and we don't actually have an element at that point in our list. So if that happens, we want to make sure that we don't actually increment this list. So this is a good technique to use, and this is something you want to make sure you keep track of. If you were to do this, you're actually going to get an error. Now, JavaScript is just going to give you a warning, but I wouldn't rely on this. Sometimes this will give you an error, and it could be a very bad error. So index out of bounds would be the error you would expect. So be careful. This is a big problem, and you want to avoid it. So be preemptive. Make sure you have this layer. Something else to point out is inside bubble 4, we see our first use of a random number. If you want to get a random number in your program, there is a function that'll do that for you. It's just random number, camel case. You give it a lower bound and an upper bound, and it'll produce a number for you between those two constraints. Now, something tricky is now with more complicated things available to us for you to use during your programs, you're going to get into more harder to spot errors. So please go slower when you program and really make sure you think everything through. This would be a very easy mistake to make. Now, this program will run fine most of the time, but every once in a while, if we just get really unlucky and we happen to roll the upper end of this list, or rather the upper end of this roll, and we roll exactly the numList.length number, we will get that error or warning, and our program could potentially crash because of that. So please, please, please make sure you think everything through. Now, you could test this a bunch of times and not get that issue. So sometimes testing your program just a couple of times isn't sufficient to really find a mistake. Last but not least, bubble number 6 here has this .join command, and the .join command is just a different way that you can add stuff to your strings. So people list is this. If you do .join, it's just going to add this /n to it. And another point that this is making is that arrays and strings are basically the same thing. An array or a string is just an array of letters. So if we look at this slide here, if I have a string called my string and it contains this or that, then every single letter is in its own little index, and you can do something like myString.length to get its length, or you could even do reference it as a particular index if you wanted to, although that's not usually useful. And you can even do this, which is substring, and that is a special function you can call in a string that'll cut a part of it away and leave you with just the bounds you desire, from 0 to 4 in this case, non-inclusive of the last number. So these are all interesting ideas, but ultimately you just need to be able to use these array ideas. So for your assignment, what you guys need to do is you need to go to lesson 3 and complete all the bubbles from 2 to 14. Don't forget to do these last two. I know they're not coding, but they're good practice for the AP exam, and I still want you guys to do them. If you have any questions about any of these, please don't hesitate to shoot me an email, and I'll be delighted to help you out. Otherwise, I hope you have a fantastic rest of your day. Stay safe, and I'll see you guys soon.